In this presentation, we're going to talk about information security. We're going to learn about integrating information security into our daily work, such as in our development iteration demonstrations, defect tracking, and postmortems. We'll discuss integrating it into our shared source code repositories, services, and into our deployment pipeline. We'll talk about how to ensure the security of our applications, our software supply chain, and our environments. We'll cover the importance of integrating security into our production telemetry and creating it in our applications and environments. And finally, we'll learn about protecting our deployment pipeline. It's important to get information security personnel involved with our feature teams as early as possible. If we wait until the end of a project to do this, it ends up being more expensive and riskier than if we do it early on. We can invite them to the product demonstrations we have at the end of each development iteration, which is often a weekly or bi-weekly sprint. This gives them a chance to see what we are building and how it is accomplishing our team goals, as well as how it fits in with our organizational goals. They'll be able to observe our projects as they are built, piece by piece, and be able to give us useful feedback. This gives our feature teams the ability to make corrections early on where they are easier and less expensive to implement. On the other hand, the knowledge the InfoSec engineers gain will help them in making decisions to minimize risk and strengthen security in our work. This knowledge can be helpful for future learning and projects as well. Traditionally, InfoSec teams have used their own issue tracking systems to track their work. A more effective way is to track these issues in the same tracking system that DevOps uses. Many organizations use a tool called Jira by Atlassian, but any similar tool can do the job. The important thing is to keep track of security issues alongside the issues that DevOps teams are working on. This provides a central place where all work is visible and facilitates the prioritization of that work as it relates to each other. As we track all our work in the same place, it's important to then have our security teams adhere to the same developmental intervals as DevOps. This brings everyone into sync and allows for unified patterns in our processes. For example, we already discussed inviting InfoSec to our product demonstrations. We should also conduct postmortems whenever security issues occur. This helps our teams understand how to prevent similar problems in the future, and as Nick Galbraith from Etsy explained, is a fantastic mechanism for transferring security knowledge to our engineering teams. Any mechanisms, tools, or libraries that help make our applications and environments secure should be stored in the same source code repositories that we use for storing application and environment source code. This provides a central place for all teams to keep their work where they can see how it relates with each other. It also provides a central place where security tools can be accessed and used in our daily work. And if we make use of shared services in our organization, we should also integrate security tools and mechanisms that are required in those services. For example, some of the items we can include are two-factor authentication libraries, password hashing, logging, connection settings, encryption keys. Some of these tools may be third-party tools such as Vault, Sneaker, Red October, etc. We can also include OS packages and builds like NTP for time syncing, OpenSSL, OSEC, or Tripwire for file integrity. Integrating these mechanisms and tools into shared code repositories and shared services makes them available to everyone, makes it easy to search for them and reuse them as needed. It gives us a place where we can get the latest versions of our tools and makes it easier to communicate and collaborate with each other and with other team members. We can even provide security training to make sure that these services and libraries are used correctly. Historically, security reviews were done after all development was complete, but we've discussed the importance of including InfoSec in the same processes as DevOps. Another step to achieve this is to automate as many of our information security tests as possible. We should then have them run alongside all other tests that we have in our deployment pipeline. Ideally, this should be performed with every code commit. The goal is to provide fast feedback to DevOps on their daily work and to detect and correct problems early and fast. There are many tools we can use to accomplish this. One example is a tool called Gauntlet, which has been designed to run automated security tests on our applications, dependencies, and environments. It can be integrated into the deployment pipeline, which allows security tests to be run on every committed change. This facilitates quick feedback, allowing DevOps to find and fix issues quickly.
Ensure security of the application. When testing in different scenarios that the code can have, we can see that there are two paths that the code can take, the happy path and the sad path. The happy path is that when everything works as planned, the order in the order that established is fulfilled, free of error and any type of tackle. On the other side, the sad path is the path where things go wrong. This is one of the which the team must focus, where all the fails that are possible must be found. This is where we can find the vulnerability point of the system, and where we should improve security in the weakest scenarios. As part of the test, should include the static analysis. This the test is sometimes known as a testing from the inside out. We perform in not running environment. Inspect program code for all possible runtime behaviors and seek out coding flags, backdoors, and potential malicious code. Dynamic analysis. This method is sometimes known as testing from outside in. As opposite of static testing, dynamic analysis considers the test execute while the program is operation. Dynamic tests monitored items such as system monitor memory, functional behavior, response time, and overall performance of the system. Dependency scanning. Another type of static testing we will normally perform at a build time inside of our deployment pipeline inventory all our dependencies for binary and executables, and ensure that are free of vulnerability or malicious binaries. Source code integrity and code signed. All packages created by the CI process should be signed, and they have recorded in the centralized login service for audit purpose. All commits for version control should be signed. That is a straightforward to configure it using the open source tools as a GitHub. Ensure security of our software supply chain. Nowadays, developers are using more code or external component such as libraries that are stored in different part of the or different repositories. We take this code for use in our software, but many times those components contain vulnerable parts that can make our code vulnerable to any failure. We must detect the vulnerability of the component that we obtain from different open sources to create a software. We must verify the sources that we are using. In this way, we maintain the security in our system. Ensure security of the environment. By using automated tests, we scan our environment to ensure that all our prepared setting has been correctly applied for configuration, also to no vulnerabilities. In order to have a secure environment, there are some tools that help us to detect failures and detect where our software might be vulnerable. Two of them are Nmap and Metalploid. Nmap is a tool for vulnerability scanning and network discovery. Identify what devices are running on the system, discovering hosts that are available in the system on the service they offer, finding open ports, and detecting security risk. Metalploid is a security tool used to attack the system or a network. It will show the vulnerability and aid the call penetration testing.
Internal security controls often fail to detect breaches. It's actually very common. So some things we can do are integrate security telemetry into the same tools that DevOps and QA are using. This makes it so that our development, operations, and Q&A teams are all able to see the telemetry information and use it to tell if there's a breach or a problem. We want to give everyone in the value stream a look at how their application is performing in a hostile environment. This enables them to see how their application responds and make fixes. And we want to make it obvious how the services are being attacked And then we should reinforce to our teams daily that countermeasures should be developed, just to make sure that they're always ready for anything that could go wrong. So I'm going to create relevant user telemetry in applications to detect fraud. This could include telemetry for user logins, both successful and unsuccessful. Whenever a user resets their password, changes their email address, or changes their credit card information. And an example of useful telemetry could be a ratio of successful versus unsuccessful logins. And then we want to create alerts for these important events. So if there's a lot of unsuccessful logins compared to successful logins, maybe there would be an alert saying, hey, there's been just a ton of unsuccessful logins. We need to do something about it. Maybe we need to look into this more. So there's so many negative things that can happen if the deployment pipeline is not protected. Source code can be stolen. Malicious code could be pushed into version control, which could just completely ruin an application. So in order to protect our applications and environments, we have to mitigate the attack vectors. So to conclude, we've talked about integrating security into development, integrating security into defect tracking, integrate preventative security controls into shared repositories, integrating security into our deployment pipeline, ensuring security of the application, ensuring security of our software supply chain, ensuring security of our environment, integrating information security into production telemetry, creating security telemetry in our applications and environments, and lastly, protecting our deployment pipeline. Any questions?